So I want to do numbers 17 and 13.4, which is sum from I is 1 to infinity x to the 2I for absolute value of x smaller than 1. Okay? So what does this start with? Yeah, it starts when I is 1, right? What do you get when you plug in I as 1 there?
X squared.
Get x squared. Crap. This doesn't look like my infinite series formula, right? I'm going to have to factor something out. So. Yeah, or you could do the -1 thing and adjust the series. That's also fine. I'm just going to factor something out here because I have that handy, but whatever. What do you get when I is 2? X to the 4th. And then the next one is x to the 6th.
Because exponent rules.
Because exponent rules. Or because 2 times 3 is 6. You do that first. And then the next one is x to the
8.
And the next one after that, Dylan, is x to the 10, and so on.
I thought we'd already.
You thought I'd done that one? No, I'm slower than that.
My brain is disintegrating.
Yeah, it's the end of
Pull
the
it back
semester.
together.
It's okay. All right, so out of this, I should be factoring a what is common among all of these things. Yeah, I want to factor an x squared out, right? And then I've got a 1 plus x squared plus x to the 4th, right? Because x squared times x to the 4th is 2x's times 4x's is 6x's. This one's 8, blah, 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 right? Okay, so what's your multiplicative factor between these things?
X squared.
Yeah, you're multiplying by x squared to get between, right? You guys all see that? Another way to see that would be to look at this first guy that we started with and think about this as x squared to the I power, right? And you should multiply the exponents in that case. Or you can do this. And then you can notice that this is x squared, and then this whole 1 plus x squared plus x to the 4th plus x to the 6th, and so on, looks like my geometric series formula. So that adds up to 1 over 1 minus x squared. Cool. Neato, check that. Cool. It should be noted that this is a valuable trick, actually. This is how you make Taylor series, kind of. And there's a way to deal with some functions that we couldn't normally deal with using this technique. So this one is good to have in your head. Cool. Questions, Gil? Can you cancel the x squared? No, thank you. Good, perfect. Where did I use this assumption that the absolute value of x is smaller than 1? Where did that happen? No.
Because you do geometric series, you have to.
Yeah, it has to be for this sum to make sense, right? Because if x is bigger than 1, then this thing just goes to infinity, right? Which tells you that this, right, this function is that sum, but only as long as x is smaller than 1, right? In absolute value. You guys see that? You could note that's when you're dividing by 0, right?
Yep.
You guys see that? So of course it's not going to work past that because that would be crazy. That's actually a really deep thing.